Welcome back. Now we are going to start our third lesson or new lesson with this house exercise. Now, we saw on last class that were able to build this house, but when we look at the variables, if you, for example, change the door height, it will overpass the wall height. So we need to impose some conditions. Well, one will be the door height, another one will be also the door position. Look, now when I move it to my left or when I move it to my right, I must apply the door to stop at the thickness of the wall, and I can't let it go over it. So for the door we have three conditions. Now when you look at the wall width, if this is too small and my thickness is too big, there will be a limit for the door insertion. So we need also to establish the minimum value for the wall width, having in mind that thickness will command everything. Okay. Then there will be also another extra condition that we are going to apply, but before all that, I have already opened our last file, and what I'm going to do is I'm going to, using the Alt key, to stretch it, and I'm going to create some parameters, numeric parameters here in primitives. I'm going to use numbers. Although some of them might be integers, I will consider all as numbers, and I'm going to count it. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I will choose one number here, and I'm going to copy paste till I have 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, the last one I will put it here, and as we saw previously, I'm going to align them here. Now the first one, I'm going to call it WW, that is wall width. The second, wall length, WL. Wall height, TH for thickness, door width, door height, roof height, roof position, and finally door position. Now, all these connections are going to be replaced by this. So I will connect wall width here, and all these that were linked, I'm going to move them so I can replace all these connections. So the first one, and to be easier, look, they are green, so I'm going to zoom out a little bit. This X is going to be there. Now another green one, it's this one, it's going to be also there. I have this multiplication, and down here I have wall width and wall width. Okay, so this one is already. Now In order to have these links invisible, if you right click in either, there is a wire display. By default, this is the thickness. You can also choose faint, that is a very thin line, or a hidden one. In hidden, you have like a receptor, Wi-Fi receptor. So when you click it, you can see the connection. When you do not select it, you see the Wi-Fi length. Now, wall length. It's going to be connected here. And we have two links. So let us zoom a little bit. The first one is getting very far away here. Wall length. So let us go back. Wall length. So one of the links was replaced. Now let us replace the other here on our vector. And there again. So second one. Now for the wall height, again double click. There are two links, one here in Z and another in Z for point E, and also here. So perfect. Now I'm going to hide. So 3 done, already done. Now thickness, it's the one we have the most, so I will let it to be the last one. So I'm going to door position here. I know that I have two links, this one and this one. Now roof position, and it's going to be there. Roof height, it's already, I'm going just to confirm this, and there, because the line were under. So these 3 I can put them hidden together. Okay, I have to do one by one. Hidden and hidden again. Now door height here, and for the door height I have these two Z's. So first one and the second here. Okay, so this one is also done. Now door width, it's connecting to the expression 1 and 2. Perfect. So I'm going to hide this also, and wireframe, hide, and now thickness. Well, as you can see, thickness, we have a lot of connections. So let us see, they all overcome. Okay, this is one of the connections. Okay, now I wanted to Rhino, so I have to do it again. Now it's Rhino, it's trying to show up, so I have to use my zoom. Okay, this one is there. This is to be replaced there. Now the second one here, this one is going to be replaced there. Now I'm going to move both of them so it will be faster and near to show where these links are, and then I will put it back. Now we saw that we have this one. Perfect. These two, so one of the connection is there. The second one will be this vector, thickness also, and it's done. So I will select both again. I'm going to put it on this right way and zoom in and hidden. So this part is very important because I need here a lot of space to create my conditions, so my commands can be here. Now, as I will need a lot of space here, my code will be very long. So what I do is I'm going to move all of this and I'm going to move it here down here, so I would have enough space here to make the conditions and then connect the conditions into the correct final width. Okay, so let us make our first condition, door height. So I'm going to copy this, copy paste, and I'm going to conditions. Okay, my conditions. Now my first condition, it's going to be wall height. Copy paste. Sorry, no, door height condition. Okay. Now, to make a condition, I have to go to maths, and I'm going to use an expression. I could use either the evaluate or the expression. As I want you to visualize what is inside here, I will choose this. Now, what is my door condition? I want that my door cannot be higher than the value that I define for the wall height. So I will have door height and also a wall height. And what I'm going to get out is my door height condition. So as you can see, we can also change the output text. Now I will double click and I will write my condition. Now my condition is always a if condition. So if bracket, and if you want to know how the if condition works, you can go here and you have here. So if test, so if my test returns true, I will execute A. If the test results into a false argument, I will do my B. So if door height is smaller or equal to the wall height, then if this is true, then I can still use the door height. If my door height is bigger than the wall height, I have to use the wall height, so we cannot overpass it. So, okay, now we are going to connect. So, door height, wall height. Now, before I connect, I can see the results to see if it's working. So I will, on parameters, input panel, I'm going to put here a panel and then look at the results. So door height is 2.97, wall height is 3.12. So I'm going to move this, and although door height is bigger than wall height, in my condition, the result is going to be this. Now, if this goes under, I will now assume this value. Now, let us connect this to our code and see if this will work. So I will connect door height condition to my door height number here. Okay, now the connection disappears because it is defined as a hidden one. Okay, so it's connected there, we can say it. Now let us now try to apply a door height bigger than my wall to see how it will work. So my wall height is 3.12 here, so let us look. Now I can put it bigger, but it stopped. So my condition is working now. This is how this kind of condition will be applied now. So door height condition, perfect. Now another thing that is very important is when I move my door position here, he has to stop immediately there. Okay? That is my limit. Now, when I move it to the other side, it will be also my limit. Now, you could be thinking that, okay, let us make the condition, but before making that condition, I must make another, that is the wall width. Okay, so my wall width must have a minimum limit, because the maximum doesn't create me any problem, but the minimum, yes. So what I'm going to do is I'm going to establish what is the minimum wall width besides the number that I've just marked on the number slide is. So I will consider that the minimum door width will be 75, and the thickness can be any value. So if I consider this thickness plus this minimum aperture for the door width, that will give me my wall width. So we'll have thickness, wall width and door width as variables So let us make the condition. So I will have thickness. I'm going to have wall width, and as I'm predefining an value for the minimum wall width, I do not need to do it, but I'm going to apply it either way. So I'm going to say door width minimum. Okay? Now I'm going to create a panel here. I will double click /forward, or I'm going to write it so quotation 0.75, that's the minimum door width, enter, and I'm going to establish this value as this. Okay, so if you want to change your door width minimum, you can do it, or if you want the wall width condition to work with the value that is established on the door width, you just have to replace it. Okay, so or make it here, so no problem at all. Now my wall width here, my thickness, and what I'm going to output here is going to be my new wall width condition. So copy, paste, and double click wall, let me write it, wall width condition. Okay, perfect. Now here I'm going to double click and write the condition. So it will be a if my wall width is smaller or equal to the, and I'm going to make here this, the thickness plus the thickness plus door width minimal. If this value is smaller than this, okay, if that is true, then the value that I want to apply will be exactly this. If not, if this is not true, that is, if this wall width is bigger than this value, then I can use the value itself. Okay? So, no errors. And I'm going to connect this on the wall width here. So if you want to know, copy paste, and let us put this smaller. Remember that when we got to 1, okay, now is not working. So thickness there, wall width there, door width minimum there. Now let us replace this here and let us make this smaller, okay? Now this door position should be halfway, so because it's considered that is halfway. Then we'll look at this. So wall width, okay, now see, and it can work independently of this. Now let me change the thickness. Okay, no problem. Let me put this to the limit. Now let me change the thickness so the width is adapting. Now you can see that we are going to have some problems with an offset. That will be our last condition to solve. So this can be smaller, and also if my door width changes, it is always adapting. So I think for our model this could be a best condition than to establish here a minimum. So here we can delete this and we can consider all this, and it's working. Now change wall width, and we are going to change also the door positions. Okay, so let us copy this. Let us put door position, and let us start with the left condition. Well, when we say left condition, we are solving it to the left side, but the value that we are going to get on the final will be always the door position, that is a middle point in this run. So now, what are the values that we need? Now, taking in consider the door position, our door position will be a point here. Now, door position is a relative value, so to have the absolute value, we must multiply the door position by the wall width. So we have door position, wall width. Now we have also to consider this point, and this point we have to divide the door width by 2. Okay, so let us start making it. Now, wall width, door width, we can zoom here, door position, and thickness is going to be important. Okay. Now, wall width, you might be intuited to connect this here. No, we have to connect this because we have to filter our wall width with the condition. So this is going to connect here because they are dependent. Okay, now door width, we don't have any condition, so we can go directly here, there. So door width here. Door position there, and thickness here. Thickness here. Now, what is going to be outputted? Now, what is being outputted is a new door position. Door position, condition left. Okay, but it's always a door position. Now, this formula is going to be very big, so let us make it by parts. So the first value that we need to test is this absolute position here minus this smaller than our thickness position or bigger? Because if it is bigger, no problem. But if it is smaller, then there is a problem. Okay? Now, double click. If, capitals, if open, and the value that I want to test is door position multiply by wall width. Okay, this is going to give me this value minus door width divided by 2, and this is going to give me this point because this is the real point that I want to test. Now let me make a space, and I'm going to make here again. If this value, or the result, because I don't need, if this value is bigger or equal to the thickness, then I can use my door position normal. But in case it's not bigger, then I have to reposition my door position. Okay, how? Now, I will have to consider that this point is here, that the middle point is going to be added half of the door width, and I will divide this value by the wall width. So I will transform an absolute value into a relative value, because our door position is always a relative value. Okay, it might seem confused, but if you pay attention and if you try to make drawings and the relationship by yourself, you will see that it's very clear and very obvious. So I will have thickness plus door width divided by 2. This is going to give me my door position, And when I divide this value by my wall width, I'm going to transform an absolute into a relative. So I will close it. Okay, so this is our door position or left condition. Okay, so I'm going to connect this. I might move this here so we can see the logical, and I'm going to apply this to my door position. So door position is there. Now let us see if this is working. Okay, to my right I didn't make it, so to my left, okay, it stopped. See, I can go to 0, but it's going to stop on the thickness. So perfect. Now to make the condition to my right side. I will need exactly the same. Here, this is down. This, instead of left, it's going to be right. And it's going to be left plus and right. Okay, so here our door position must be connected there. So I'm going to move this here, this one here, and what will be outputted there is going to be connected with our position. So this is the end of the door position. Okay, now to my right. Now, instead of having here a minus, I must have a plus, because I'm consider the door position here, that is multiplied by the wall width, is going to give me an absolute value plus half of the door width. Now, if this is equals to my wall width minus my thickness, if that is smaller, then it means that this point never arrives here. But if it's bigger, then I have the problem. So double click. Now this is going to be plus, and this must be minor or equal to wall width minus thickness. Now, if this is true, I can still keep my door position. But if this is not true, then I have to consider a limit value. And the limit value is going to be wall width minus thickness minus door width divided by 2. Now here I get my door position absolute value, but if I divided it again by the wall width, I will transform the value into relative as we did before. So let us put wall width, we need to divide, so wall width minus thickness minus door width divided by 2, all this divided by wall width is going to give me my new position. Okay? So here I'm having a problem, so let me see. WW, it's okay. TH, DW, divided by 2. So syntax operator not defined, or bool and double. So let's consider this. Okay, this is the first. Second, close. This is okay. Minus. Let me put plus. Okay, now no syntax error detecting the expression. So sometimes you have to review this because of the multiplication plus. Okay, so we can see now it's green. So let us try to my right position. Making bigger, 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 and it stopped. So perfect. Door height, door position, wall width. Now the only value or the only condition that at this time we need to do is to review the part of the offset. So before that, let us try to make wall width, and let us see if we are going to get any errors, like we're having, okay, see? When I do, see how the thickness change here? Now, here we had the problem, so let's try to solve this problem. Right, so I'm going to move this, all this, here. I'm going to connect all these and group them as conditions. Well, I should also join the condition here. So I select on the condition, on the text, and on the group. Right mouse click here over the group and add to group. So perfect. Variables also grouped. And here I'm going to put it exactly where it was, and here. And what I'm going to do is I have profile B, so I will drag here profile B. I will see where I have my offset, it's there, and pressing the Alt key I'm going to rebuild this. Now I'm going to have to hide the profiles. I will have to hide the final results, and I have to turn on the polyline and my offset. See, my offset is getting out. So here I have a negative one, and I'm going to copy these two, copy paste here. Well, I want to transform, so I could click here and go there. Now, to be faster, I'm going to copy a negative. So a negative of a negative is a positive. Okay, so I have one curve, another one. Now, I will have to test these two curves to see which one of them are into the interior. Well, we could use a lot of ways to do that. Now, if you look here, you see that on the interior we'll get a smaller perimeter. So we can see which one has the smaller perimeter, and the smaller perimeter will be in the interior and the bigger perimeter on the exterior. Well, this is a way. You could, for example, draw a line between this endpoint and this one and see which one of these intersects that line. Of course, the interior will always intersect and the exterior will not intersect. Now, this is another way to choose which one of them we want. Now, let us go by perimeter. Now, if I go to curve analysis, I have here a lot of stuff. So I will need some information about my curve. So if I go to utilities, I can have here a lot, or if I write area, I got the center and the area. Of course, this perimeter is smaller, so the area is always smaller, so that's another one. Length. This is going to give me my perimeter. The length of the curve is going to give me the perimeter. So I will delete this and I will lose the length. So copy paste. I'm going to move it here slightly down. So this one and this. And to help me throughout the process, I will use panels. Well, panels will give me the value that is being outputted, so I can confirm they are the same. Okay, so see now. To know which one is the smallest one, I have to ask now, what is my reference value? Okay, this is smaller than this, perfect, but in this case I need to have a medium reference, and my medium reference is going to be my polyline. So I will ask Ctrl C, Ctrl V, if this can be up, smaller, smaller, so like this. Okay, I'm going to ask if this is smaller than this, and if this is smaller than this. Now, as you see here, the level of hierarchy is different, so I have to put all of them in the same level. But I also have to join these two. So I'm going to merge, and I'm going to merge this one with this. So what I'm going to get is this, the two values. Now remember that we need to make them at the same level of hierarchy. So if you double click and write flatten tree, you connect this here. Let us use this. Well, I'm using the panel so you can go see the process. Now the values are here, but the levels now are the same. If you can ask me, where do I get the flatten besides writing? So Control Alt flatten, Control Alt flatten, it's on sets tree flatten tree. Okay, and the merge is also sets tree merge. The length is curve analysis length. Okay, and the offset curve utility offset, and the negative is maths operations negative. Okay, so here is perfect. So I'm going just to move this slightly here so we can have in parallel the two values. I'm going to spread or stretch again these two ones. I want it near. This is going to be farther, and I'm going to make a condition. Well, as you see, we can use a lot conditions. At least I like to use a lot. So I will consider x and y. This is x, this is y. I also told you that when we have one value being outputted, we have just a straight line. If we have more than one value in the same level, we have two parallel lines. And if we have several branches with more than one element, we'll have a double hidden line or dashed line. So here my formula will be if x, that is this value, is it smaller than this one, then y, okay? If it is smaller, it will be true. If not, false. Okay? So what do we get out of here? So let us copy another panel and connect. Okay? So the first value of our merge is true, and the second one is false. Now, we could do this like this, or I could merge the two lines, then asking for the offset, but I'm going to use this. Now, how do I use this true-false? There is a command over sets that is called cool. Cool is remove elements from a list. So we have cool index. Here I'm going to define if I want to remove the 0 index or the first one or any other index. Every a certain number of elements of a list, or in a pattern. My pattern is a true false or 0 1 value. So I'm going to cool out, I'm going to eliminate a list over the cool. So my pattern of elimination is going to be this result. So this is my pattern. Now, what are my lists? In fact, my list, it's going to be the merge of these two offsets. Okay, so I join these lengths 1, 2. So these were the first one. This is important, and this is the second. Okay, so by joining them, if I wanted to make a perfect code, this merge shouldn't occur here, but here. Okay, so either way, I'm going to be there. Now, what is being output here? What is being outputted is a circle, a polyline curve. That is, here I select which one I wanted. So if you hide everything, and let just this, okay, in this case this is getting me the opposite, so I have here to reverse the number. See, okay, now it's correct. Now it's getting me the interior one. That's the one I want. So let us see if I change the wall width, okay, it's always there. Okay, I'm always choosing the smallest or the interior one, so that problem is solved. So remember, from here we connected this one that was giving the error. We're connecting here and there. So now we connect the cool into the end, and we'll connect the cool to the D3. And like this, let us just stretch it apart. Like this, I've just solved this problem. Now I'm going to select all these plus this group, and let me do again, choose all of them, the group, right click over the group and add to group. Okay, so this can go down here to the left, and now if we hide this and we ask this one visible, it's always going to be in the interior. This one is going to be hidden, and now this open, and this one also open. So we've created all the conditions, and we can still conclude or make it here a final object. So if we go to intersect shape, we can create solid union. Okay, it's expecting to have here a lot. Now, as we have 3 objects, I'm going to create my merge. Well, you know that we don't need it, but I make it to be easier to remove or to add elements. This is now going to be hidden, hidden, and hidden. They are merged, and I'm going to see how they were merged into a list, not into one object, but into a list. So we have different branches, so that's why we got this kind of representation. So again, a flatten will be perfect because they will now be on the side. So this is going to be hidden, and I'm going to join both. So here is not letting data conversion fail into transform, so we got here an error. We can consider this as our final result, or we can use this boundary volume. Okay, it's also giving error. So we'll consider this as our final object. Okay, hope you enjoyed it, and see you soon on the next exercise. Oh, don't forget to save this file, save as. This will be exercise 2.3. Okay, remember that minus your number minus your name. Okay, here lower. Okay, save it to your desktop or where you want as a grasshopper, and then do file export high resolution. Here on the alpha channel, it's having alpha, so I'm going to take the alpha away because I want a white background. Because applying to the website will be easier unless you have a color background website or you want to apply a color to your portfolio. So if that is the case, choose alpha channels 255, otherwise alpha channel 0. Give also the name 2.3, your number, full student name with no spaces, save. We will waiting for a little bit. Now it's producing. It will be a very big image, but a small file. Okay, thank you and see you next time. Bye.